how do we find this y? Or a better question is, what were the conditions that we needed on this y? What did we need out of this y? Well, we wanted that when we plug this y in, that the left-hand side was the objective function. Actually, we just need that it's at least the objective function. If the left-hand side would have been x1 plus 7x2 plus 10x3, then that still would have served as an upper bound on the objective function. That would be only bigger, so any upper bound on that new function would serve as an upper bound also on the original objective function. So let's ignore this specific y. What are the conditions, once again, that we need on this y? Well, we need that this left-hand side is at least the objective function. So we need that the coefficient for x1, which is y1 plus y3, we need this to be at least the coefficient of x1 in the objective function. So we need that y1 plus y3 is at least 1. Similarly, for x2, we need that y2 plus 3y3 plus y4 is at least 6, and 2y3 plus 3y4 is at least 10. Now any y satisfying these three constraints, when we plug it in, the left-hand side will be at least the value of the objective function. So the right-hand side will serve as an upper bound on the left-hand side, and therefore is also an upper bound on the original objective function. So any y satisfying these three constraints yields an upper bound on the objective function. So we want to get the smallest possible upper bound. So we want to minimize the right-hand side. In this way we get the smallest possible upper bound. So our objective is to minimize 300y1 plus 200y2 plus 1000y3 plus 500y4. This is the right-hand side here. And this is our dual LP. This is in fact a linear program. We're just trying to find the feasible y's, those y's satisfying these three constraints, and we want to find the feasible y which minimizes this objective function. So our original LP had a maximization, now we have a minimization, and our constraints originally were less than or equal to constraints, and now they flipped to at least constraints. And notice that all these numbers, these coefficients, are related to the original LP. Look, in our new objective function, where did we get 300, 200, 1000, 500 from? Well, these are the right-hand sides here. The right-hand sides there came from the right-hand sides of the original constraints. So the right-hand sides of the original constraints tell us the coefficients for our new LP. Where did the right-hand sides for these three constraints come from? Well, these came from the coefficients in the objective function. So the coefficients in the original objective function define the right-hand sides in this dual LP constraints. And the right-hand sides in the original LP constraints define the objective function in this dual LP. So there's this sort of symmetry. Finally, where do the left-hand side of the constraints come from? Well, this first constraint, these are the terms which contain x1. Which constraints contain x1? Well, the first constraint and the third constraint contain x1. And therefore, y1 and y3 appear in the first constraint. Which constraints contain x2? The second one, the third one, and the fourth one. And therefore, in the second constraint, we have y2, y3, and y4 appear, because the second, third, and fourth contain x2. One last note. Notice we have four constraints in the original LP. We're going to take a linear combination of these four constraints. We want to find out what are the coefficients in that linear combination. So our variables, we're going to have four variables in our new LP, one corresponding to each of the constraints. So if there are four constraints, our new LP will have four variables. And our original LP had three variables, and that's going to yield three constraints, because we have to look at the coefficients for each of those variables and make sure they're at least the coefficients in the original objective function. So the number of variables in the original LP defines the number of constraints in the new LP, the dual LP, and the number of constraints in the original LP defines the number of variables in the new dual LP.